We'll continue Module 2, that is Digital Switching Systems. Digital Switching System Fundamentals. The concept of SPC is extended to modern DSS. The basic element of DSS is similar to that of SPC switching system. A switching system is called digital when the input and the output from the switching system network can directly support digital signals. Digital signals can be defined as coded pulses that can be used for signaling and control. However, analog signal can still be processed through the DSS via analog to digital converter or digital to analog converter. Figure shows a digital switch evolution, that is analog lines and analog switch and analog trunks. The second one is analog lines, digital switch and analog trunks, that is analog to digital and digital to analog conversion. Likewise, figure C shows analog lines and digital trunks and analog trunks. Figure D, that is digital lines, digital trunks and digital trunks. The evolution of the digital switching from analog switching is as shown in the figure A to D. Figure A shows a typical analog switch with the analog lines and the trunks. It shows the trunk side and the line side of a switch. The basic functionality of switching system is to switch lines and trunks. The main objective of the DSS is to switch the subscriber and the trunk facilities. Figure B shows the next step in the evolution of the DSS. This phase uses analog lines and analog trunks but employs analog to digital and digital to analog converters for digital call processing of calls. The switching element in the digital means that digital signals are sent through the switch. Figure C shows the next step in the digital switch, where digital switch talks to other digital switch using digital trunks simultaneously supporting analog lines and trunks. Figure D shows the ultimate and all digital linkage. Here there is no analog links and trunks involved. All communication between digital switches via digital signaling. This plan assumes that all incoming and outgoing calls from the digital switch are digital. The modern DSS supports both audio, video and internet support. So still the modern DSS support analog and digital conversions. Optical switching is the future of the telephony switching. Optical switching systems provide high-speed, large bandwidth switching. Optical switches are under development. In case of optical switching, optical to electrical and electrical to optical conversion will be required. Building blocks of digital switching systems. The development of DSS model is described in 4 stages. The 4 stages are explained as below. Stage 1. Stage 1 of conceiving DSS are shown in the figure. At this stage, all inputs and the outputs, that is lines and the trunks, are defined. This stage explains the very basic kernel of a DSS with the switching fabric. The switching fabric switches lines and the trunks under the control of a central processor and network controller. Switching fabric is a switched path through the CO. First stage of the lines and the trunks, switching fabric and network controller. So central processor, trunks and lines. Stage 2. Stage 2 of a DSS is as shown in the figure B. The concept of line modules and the trunk modules are introduced here. These are building blocks of a modern DSS. The lines or trunks are grouped together on the circuit packs called as line or trunk equipment, and they connected to the switching fabric through a controlling interface. This is the second stage of line modules and the trunk. Some DSS allow termination of only one line on one line module, while others allow termination of multiple lines on a single line module. Both schemes have pros and cons. The advantages of first method is if a line module become defective and a line can be easily assigned to a new piece of line equipment. The disadvantage of later method is if a line goes defective, this may impact a number of multiple lines if the line module carries multiple lines. Similar schemes used for trunk and the trunk modules. Stage 3. Stage 3 of a DSS is as shown in the figure C. This stage introduces the concept of interface controller for LM and TMs and distributed processing systems. This stage replaces the network controller by network control processor. The task of controlling the switching fabric is usually assigned to a series of NCPs that control a part of the switching matrix and a group of LMs and TMs. The central processor controls all the network processors. Most of the DSS use the concept of central processor and the many NCPs. This helps in a easy increase of network size. Stage 4. Stage 4 is a final stage of DSS as shown in the figure D. This level represents the high-level design of a DSS equipped with interface controller and the service circuits to the line and the trunk modules. In reality, it is an initial module of a DSS. Here, duplicated scheme is introduced. Since telephony processing is a non-stop process, requires high reliability and memory for processing the telephonic events. Interface controller connects the LMs and TMs. The purpose of service circuits is to provide dial tone, ringing, and other functions. This is the fourth stage of redundant processors. Basic call processing. There are four types of call processed through a digital switching system. They are intra-LM calls, inter-LM calls, incoming calls, and outgoing calls. Intra-LM calls. It is a call within the digital switching system. For example, when a customer goes half hook and dials a telephone number of another person who is connected to the same line module. Intra-LM path is as shown in the figure. The half-hook condition is detected by the line modules and the service circuit provides the dial tone to the calling customers. The LM requests the path through the switching matrix and processed by the interface controller, which in turn control the network control processor to assign the path. Consequently, a path is established between the called party and the calling party through the switching matrix, and the service circuit provides the ringing tone. The inter-LM calls. Interline module call is nothing but a call processing between the two DSS. For example, when a customer goes half hook and dials a telephone number of another person who is connected to another line number, inter-LM call path is as shown in the figure. Outgoing calls. When a line model processes a call which has terminating equipment outside the central office, the LM requests for the path through the switching matrix to a trunk module via the interface controller. IC works with the NCP to establish a path to an outgoing trunk. Once a path is established through the switching matrix, the trunk module connects a service circuit for the controlling the call to the called CO. The special function of DTME, MF and the outpulsing are provided trunk service circuits. An outgoing call from an originating office is an incoming call to a terminating office. The path for the incoming and outgoing call as shown in the figure. Incoming calls. When a TM detects an incoming call, the trunk module requests for a path through the switching matrix from the interface controller and the NCP. Once the path is detected, the switching matrix to LM that has the terminating line. The service circuit provides the ring to the call telephone equipment.